Today we shall start with the chapter continuity. This chapter is very important from the point of view of the examination of IIT, RPSC second grade, first grade, everywhere. At least one question always appears in every examination. Chapter A is very important and it is connected with the limit of the connected with the chapter of the limit. So before studying this chapter, you should know everything about the limit. What is the meaning of the left limit? What is the meaning of the right limit? Everywhere. And that I have uploaded video for limit. So before studying this one, you study chapter of the limit part first. Limit video for the limit part 1. Limit part 1. Now, let us see what is the meaning of the continuity. What it says, a function fx shall be continuous at any point x equal to a in its domain if left limit at x equal to a, that is limit x tends to a minus fx, or what you can say, limit h tends to 0, limit h tends to 0 f of a minus h is equal to right limit, that is limit x tends to a plus fx, that is this is equal to limit h tends to 0 f of a plus hh, and this is equal to value of the function, that is left limit should be equal to right limit, and that should be equal to value of the function at x equal to a, that is fa. I am repeating it again. A function fx at x equal to a in its domain shall be continuous at x equal to a if at x equal to a left limit is equal to right limit, and that is equal to value of the function. So naturally, what you have to see, how to find the left limit, how to find the right limit, and how these questions can be converted to objective type of the question. So we shall keep in mind three things. First thing is this, that if function is step function, to find the left limit, you take the function which is defined for less than a. Similarly, to find the right limit, you take the function which is defined for greater than a. First point. Second point, limiting value and actual value of the polynomials is always equal, and that is equal to value of the function. That is equal to value of the function. So what we can say, that polynomials are continuous everywhere. Polynomials are continuous everywhere. Next point is this, if a function is not defined at any point, then it shall not be continuous at that point. So if you keep in mind all these three things, first thing, how to find the left limit, how to find the right limit, how to deal with the step functions, and then polynomials are continuous everywhere. And the last point, if function is not defined at any point, then it shall not be continuous at that point. So let us see how we can do these questions. Fx equal to mod of x minus 1. Then what he says, correct statement is only continuous at x equal to 1. Second statement is only discontinuous at x equal to 1. What he says, continuous everywhere and discontinuous everywhere. Let us see how we can deal with this function. Okay? So, fx equal to, this is 1 minus x when x is less than equal to 1, x minus 1 when x is greater than 1. Now, this is a step function and it is defined in different ways, in left of 1 and right of 1. So, to find the limit in left of 1, this is a 1 minus x. So, limiting value and actual value shall be same. So, limit x tends to 1 minus fx is equal to 0. Similarly, limit x tends to 1 plus fx you put x equal to 1 and that will be 0. What is f1? f1 is 0. So one thing is sure, that at x equal to 1, left limit is equal to right limit and that is equal to value of the function. So function is continuous at x equal to 1. One thing is sure. Now let us see all the values other than 1. So for less than 1, it is a polynomial of 1 degree. For greater than 1, it is a polynomial of the 1 degree. So it is continuous everywhere. For less than 1, for greater than 1, and at x equal to 1, we have checked it is continuous. So answer is continuous everywhere. You can do this question orally. You write the function fx equal to 1 minus x, x minus 1, less than 1, greater than 1, left limit is 1 minus 1, 0, right limit is 1 minus 1, 0, and for less than 1 it is polynomial, greater than 1 it is polynomial. So function is continuous everywhere. Function is continuous everywhere. Let us see. Fx equal to mod of x minus 1 plus mod of x. So, if you wish, you can do it orally. Mod of x minus 1 is continuous everywhere. Mod of x is continuous everywhere. So, it will be continuous everywhere. We have done it. Mod of x minus 1 is continuous everywhere. Similarly, mod of x minus 1 is continuous everywhere. Mod of x shall be continuous everywhere. So, what you can say that it is addition of the two continuous function. So, it is continuous everywhere. Now, as a result, you can remember fx equal to mod of x minus a is continuous everywhere. Okay. Next one. Function is fx equal to mod of x upon xa. What is h? Continuous at x equal to 0. Continuous in the right of x equal to 0. Continuous in the left of x equal to 0. None. So this is fx equal to minus 1 when x is less than 0. 1, x is greater than 0. So what we see, In the left of 0, it is minus 1. In right of 0, it is 1. Left limit is not equal to right limit. Left limit is not equal to right limit. So function is not continuous. Function is not continuous at x equal to 0. Then what we see? In left of 0, lesser than 0, it is a constant function, minus 1. In right of 0, it is a constant function, that is 1. Constant functions are always continuous. So, what we can see, continuous in the right of x equal to 0, continuous in the left of x equal to 0. So, answer is B and C. How I have written this function? That you have to study in my previous video, step functions. So, before studying this chapter, you go through step functions, limit, and then continuity. Fx equal to e raised to 1 upon x. Now in the chapter of limit, we have seen it that limit of the function e raised to 1 upon x does not lie at x equal to 0. Limit of the function at x equal to 0, function is e raised to 1 upon x, is not existing. So naturally, it shall not be continuous at x equal to 0. Now, let us see what about other results. E raised to 1 upon x is a polynomial. According to, we can expand e raised to x equal to 1 plus x square upon factorial 2, so on. So what we see, function is only discontinuous at x equal to 0, otherwise it is a polynomial, so it will be continuous. Next, see, fx equal to x minus 1, when x is less than 0, x square plus 2x plus 1, when x is greater than or equal to 0, it is a step function. It is defined in different ways in left of 0 and right of 0. So, let us see, left limit f of 0 minus h, limit h tends to 0, f of 0 minus h is equal to minus 1, f of 0 plus h is 1 and f0 is 1. f0 is 1. Left limit is not equal to right limit. So, function is not continuous at x equal to 0. Let us see, for less than 0, function is x minus 1. So, it is 1 degree polynomial. So, it shall be continuous everywhere. For greater than 0, it is a polynomial of second degree. So, it shall be continuous everywhere. So, what we conclude? Function is only discontinuous at x equal to 0. Function is only discontinuous at x equal to 0. Let us see. Fx equal to x sin 1 upon x when x is not equal to 0, 0 when x equal to 0. Let us see what we can do. If we find left limit, so f of 0 minus h, limit h tends to 0 shall be equal to 0 minus h sine 1 upon 0 minus h. Limit h tends to 0. Value of sine theta always lies in between minus 1 and 1, and when it will be multiplied by h tends to 0 means 0. So this will be 0. Similarly, limit h tends to 0, f of 0 plus h will be equal to 0 plus h sine 1 upon 0 plus h. So limit h tends to 0, limit h tends to 0, f of 0 plus h shall be 0. f0 he has given 0. So left limit at x equal to 0 is right limit at x equal to 0, and that is equal to 0. Now what about values other than 0? For values other than 0, x sine 1 upon x, sine 1 upon x can be expanded and it will be a polynomial, so continuous everywhere. So what we conclude? Function is continuous at x equal to 0 and function is continuous all the other values. So function is continuous everywhere. Function is continuous everywhere. We always keep in mind that polynomials are continuous everywhere. Let us see. Which of the following function is continuous at x equal to 0? Sine 1 upon x, limit of the sine 1 upon x does not exist at x equal to 0. In the chapter of limit, I have mentioned it because it will be an oscillating function in between minus 1 and 1. So, limit of the function sine 1 upon x does not exist at x equal to 0. Limit of the function e raised to 1 upon x, again we have done it in the chapter of limit. Before studying this chapter, you go through first chapter of the limit, so it is not existing. Similarly, cos 1 upon x is always or is not existing, so none. Question number 9. Any function this is not continuous. Question number 10, we are done. You get fx equal to, this is very important question, fx equal to x raised to m sine 1 upon x, x is not equal to 0, 0 when x equal to 0. So, f of 0 plus h limit h tends to 0 is equal to 0 plus h raised to m sine 1 upon h. F of 0 minus h limit h tends to 0 minus h raised to m sine of 1 upon minus h. F of 0 minus h is this, and this should be equal to this should be equal to 0. It is only possible when m is positive. M is any positive. In that condition, it will be 0 into something. It will be 0 into something. So, answer is m is greater than 0. Once this question has been asked in competitive exam, you can write it like this. Right limit is equal to left limit. This is equal to this. Okay. Now, the last question which I am doing, fx equal to greatest integer x, only continuous on integers, only discontinuous on integers, continuous everywhere, discontinuous everywhere. So if I take fx equal to greatest integer x, let us test the continuity at x equal to m. M is integer. Limit h tends to 0, greatest integer m minus h, that will be equal to m minus 1. Similarly, limit h tends to 0, greatest integer m plus h, that is equal to m. Now, all these two things, I have mentioned them in the chapter, in the video step functions. So, I am repeating it again. Before doing this chapter, you have to go through two videos. One is step function and another is limit part 1. Limit part 1. So, one thing is sure that at integer it is not continuous. Now, what about non-integers? So, if you take half, it is not integer. So, limit h tends to 0, half minus h will be equal to 0, limit h tends to 0, half plus h will be equal to 0, and greatest integer half will be 0. So, what we can see, if it is a non-integral value, function shall be continuous. So, what you can say, only discontinuous on integers. This is important question, and to understand this question, you have to go through previous video, step functions and chapter of limit part 1. Similarly, you can do this question number 14 you can do, same integral values. So, next is, next part, what we do, to test the limit, what we have seen, it should be, left limit should be equal to right limit, that should be equal to value of the function. Now, second type of the questions are more or less question of the limit. So, what he says, if a function fx is continuous at x equal to a, shall be continuous? No. What is saying? If a function fx is continuous at x equal to a, then limit x tends to a will be equal to fa. Limit x tends to a, fx is equal to fa. So, let us see this question. Fx equal to x plus sin x upon x when x is not equal to 0, and lambda when x equal to 0. So, a function is continuous at x equal to a, limit x tends to 0, x plus sin x upon x should be equal to lambda. Take the limit of this, x upon x will be equal to 1, sin x upon x will be equal to 1. So, lambda shall be equal to 2. Answer is lambda equal to 2. He has given many questions. They are more or less question of the limit. Example, 1 plus 2x raised to 1 upon x. So, limit x tends to 0. 1 plus 2x raised to 1 upon x, this should be equal to lambda. If it is a 2, reciprocal should be here, 1 upon 2x, that should be equal to 2. So, lambda will be equal to e square. Once this question has been asked in competitive exam, it is more or less question of the limit. I have applied here, limit x tends to 0, 1 plus x raised to 1 upon x is equal to e. Limit x tends to 0, 1 plus x raised to 1 upon x minus upon 1 minus x. So, this is equal to limit x tends to 0, 1 plus x raised to 1 upon x, 1 minus x raised to 1 upon x. This is e raised to minus 1 because I shall multiply and divide by minus 1. So, this will be equal to e square. So, value of the lambda is e square. This is the answer. I have done many questions for you. I have done 17 questions. Now, what is the property of the continuity? What it says, if fx and gx are both continuous, then fx and gx are both continuous, then fx plus minus gx, fx into gx shall also be continuous. Next is, if fx and gx are two functions and fx is continuous, gx is not continuous, then fx plus minus gx shall not be continuous. But fx into gx may or may be continuous. What I want to say, if fx and gx, fx and gx both are continuous, then fx plus minus gx, fx into gx, fx minus gx all will be continuous. Fx not continuous, gx not continuous. Then fx plus minus gx, fx plus minus gx shall not be continuous, but fx into gx may or may not be continuous. Fx into gx may or may not be continuous. So, fx and gx, fx equal to x दिया है, तो x plus greatest integer discontinuous होगा, x minus greatest integer discontinuous होगा, x plus greatest integer x continuous है at x equal to 1 कह रहा है, x minus greatest integer x discontinuous होगा. तो which is not true. Because x will be continuous at x equal to 1, greatest integer x shall not be continuous. This is discontinuous. This is at x equal to 1. It is not continuous. So, x plus x, greatest integer x, continuous नहीं होगा. It is good question.